Good morning and welcome to 3 ways to reduce your manufacturing floor cost. My name is Stephanie Price. I'm a senior applications engineer here at Promess Incorporated. And with me today is Adam Christensen.
I'm Adam Christensen. I am an applications engineer here at Promess. I've been here for about 5 years.
So today we're going to talk about reducing costs, right? And we have 3 ways that we want to kind of dig deeper into that. 1, reducing your scrap rate. 2, improving your part quality. And 3, avoiding shipping bad parts.
So we'll have a Q&A at the very end of the webinar today. Feel free to put any questions in to the chat and we can answer those at the end. Those will be on the right side of the screen.
So just a kind of quick thought as to why we chose this topic. As application engineers, outside of going out and servicing the product, both Adam and I work really closely with our customers and their process and the different pain points that they have within their manufacturing fields.
So yeah, we've been out there and been in the field before and just seen kind of the pain points of using some of the maybe a little bit older technology or just other technology as well. So this is something that we've compiled over time that we're kind of going to go over with you on this webinar.
Right. So let's take a look at the first one,
Yep.
right? Reducing scrap rates. As you can assume, when you make a bad part, right, it's definitely more expensive if you're trying to rework the part or you're not finding that mistake until further on down the line.
Yep. And then it's always more cost when down the line. So not only that, but you have end of line gauging and everything down the line. And then you have other sensors and whatnot that you have to invest in as well.
And some of that older technology, right? You didn't necessarily know what was going on with the process. There wasn't necessarily a force feedback or any distance feedback.
Yep, correct.
And that's really important to have so that you can understand what's going on. And then once you understand what's going on, then you have the ability to put limits around that process, which is key, right, in reducing scrap rate.
So not only that, but I mean, you can go, like Stephanie said here, you can go to like a force or a distance with the Promess presses here. With some other technologies, you don't have that kind of flexibility with it. If you have a part that you're driving down to a shoulder, then you can set a force to drive down to that shoulder to make sure you're at that shoulder and also at the same position as well. At the same time, taking that monitoring feedback of your force versus position or force over time graphs, and then also putting some limits around that as well.
For sure. And then you had touched on, Adam, in regards to end-of-line testing, which is really how a lot of processes were done. Even just a few years ago, you would assemble the part, then take it to an offline station, and then you would gauge and look to verify that the part was made within spec. The problem becomes, though, that the gauging tools that you're using aren't necessarily the same tools that you're using to put the part together. So what happens is that when the part is out of spec, then you have to figure out what is the reason for the part being out of spec. Is it faulty tools on the end-of-line test side, or is it something that's going on within your process? You're taking time away to do the underlying test to begin with, as well as figure out then at that point where the breakdown in the process was. But if you can take that end-of-line testing and incorporate it into your process, then you've eliminated the cost of a station.
Correct.
And you've also eliminated the time to figure out what's going on, because you see now right within your process where the breakdown was, and you're able to fix it more reliable. And as we all know, time is money. So if you can save time, you can save money.
And at the same time too, I've worked on applications where they've had some sort of end-of-line testing, some sensors or cameras, stuff like that. And they've actually been able to not only use our press and get the monitoring feedback from the press unit, but at the same time, they started gauging parts because their past process then caused them to gauge every single part that came through. So then after they ran with our Promess press and they were getting all that monitoring feedback, they had that confidence that they started gauging once every 100 parts. And then that once every 100 parts became once every 500 parts and stuff like that. And eventually at that end of line testing or gauging that they were doing at the very end, they were able to take out of the station as well and save some cost.
Yeah, they definitely were able to get more confidence
Yep.
with the data that they were getting as they went more
Yep.
on with the process. Another thing to think about is limits around, you want something that can be flexible and easy to change. Even though you need to be very specific with your part tolerances, there's times when those parts may be a little bit more compliant or not as compliant. And so you want to have the flexibility of programming. And we're going to touch that a little bit further on too with this conversation, but I just wanted to throw that out there right now.
Yeah, so basically you can take offsets of some limits further downstream, or that the parts are getting assembled upstream from the part, and send those through as well. The flexibility is there to take the limits then and create some offsets as well. So we'll touch on that. Kind of moves us into the next, improving the part quality.
So improving that part quality, right?
Yep.
I mean, consistency is key to having a good part. And so you want to make sure that you're making the same part all the time.
So it's one thing Stephanie was touching on too, if you're making that same part every single time. So within the software, you're able to press, say, a perfect part, or even take an imperfect part and press it to a tolerance and take those same limits then and call it your perfect part. And then you can gauge from there. So with the system, not only can you take historical graphs, so if you've had other parts that have been run before, you can combine historical graph and take averages of those to create some limits as well and some deviations from there. And then also you can target, say, your forces and positions off of that as well.
Right, and you want to make sure that the system that you have is actually repeatable. And I think we have a really nice graphic that kind of demonstrates this, the difference between accuracy and repeatability, because we get asked that a lot, you know, especially when somebody's in the beginning of their process and they're looking for accuracy, which is great, right? You want to be able to hit the target that you're going to, but you want to make sure that there's also that repeatability, so that you're also not just having the accuracy, but the repeatability in the system in order to make that part right each time.
Because eventually you don't want to have a machine that is precise but not accurate. So then you have to put offsets in for your parts at that point. And that's another thing that could take time and money away from your production line as well. If you're sitting there always chasing these offsets and you're chasing all this variability that goes on within your parts, that's going to take time and money away from your production line.
And speaking about precise, right? In the past, a lot of our customers would have very precise parts machined so that they could make sure that their part was perfect every time. But to have a very precise machined part, for lack of a better word, it would take a lot of money and a lot of time.
Correct.
But if you can make your parts just slightly less perfect, right? But then you're able to compensate for those using a touch point or pressing to a force relative to where you meet the part, then you can save money on the cost of the part that you're using.
Yeah, and one example I have, and forgive me if I'm long-winded here, but we had an application where the bushing that was actually pressed into a sleeve, the customer before used an air press, and what the air press did is it just drove it down to his shoulder. We were basically doing the same thing with our unit, driving it down to his shoulder, but what they had found before is they just estimated what these pressing forces actually was on the part. So they were sending their sleeves out to be etched or tumbled on the inside, so that way it would up the press forces while that press or that bushing was being pressed into the sleeve. You'd have a higher interference fit. When we started pressing in some bushings, we found that the actual interference fit was too high from the part print because of the fact that they were etching or tumbling their parts on the inside. What we actually found is we took a few sleeves without being tumbled and pressed a part in, and it was right around the same exact what they needed for their part print. They were actually able to save money with that because of the fact that they didn't have to have another process. And this particular customer was shipping their parts out to be etched or tumbled as well. So they actually saved money. Exactly, they saved money in that exact way.
A control arm, you know, you were talking machines, and a control arm is what really brings to mind for me. You know, a lot of times the parts have to be pressed in relation to a datum point on the control arm. And so being able to take in multiple sensors and actually use the part and how it was created to press to that, that again saved our customer a lot of time and money with reworks,
Yeah.
right?
And if you remember too, with control arms, a lot of times it's just stamped parts, and then they're welded together. So whenever you weld those together, your part is going to flex a little bit, or the pitch of the part could be greater or less than. So a lot of the times you take a datum point within that control arm, and you can take your whatever your master part is at that point, and you can take and offset where those bushings are going to go relative to a datum point on that control arm. Not only that, but you're also integrating probes into our system and going to either a probe position,
Right.
taking a force or a press position, and also taking a couple other sensors, say if you have 2 probes, and putting those together as well as a sum or a maximum or minimum, and going to a target or a function force there. So.
And I think that's really powerful, what you were just touching upon, being able to take in multiple sensors in order to help improve that part quality, because you have one controller then who's able to take in the force sensor, take in the position sensor, take in the encoder, and use that and incorporated it in real time, as opposed to trying to get the data from either a PLC or downstream or further on, to make those decisions that need to be done in process.
Yeah, that's a great point. And even taking account in for stack ups on your parts or your pallet height, stuff like that. So imagine if you come down with a pin press that's pressing into a small hole, and you're not taking the press down to a shoulder, or you're taking that part down to the shoulder. You're actually just going to touch the part and then go relative from there, because it has to set a certain depth within, say, that hole or that part at the same time. We're able to do that, go down to a small force and go relative to either a force depth or also a position depth as well.
Right, and that definitely is application or a process that we use quite often in the field. So,
and a lot of times you can actually do that with the press, with the position and the force as well. There are special applications, maybe you need some probes, but it's all within one package, say, of just going to a touch point and then relative from there into wherever your critical dimension is that you're going to as well. So the press itself is the complete package with the force over position as well.
Right. So the third thing that we wanted to talk about, right, we've talked about improving part quality, we've talked about reducing scrap, but avoiding shipping bad parts, right? And really, when I think about avoiding shipping bad parts, we have, the pass and fail with the limits and everything that we talked about in the last 2 sessions, but, really data. I mean, in the years that I've been with Promess, I would say that the further on we go within the company, the more and more you're hearing customers talk about data. As the industry, Internet of Things, Industry 4.0 is becoming more of a topic. People are looking to see, okay, I have this data, right? What do I do with it? And first and foremost, just being able to collect the data, having those sensors come in, all right, and not just using them, but storing that, so you can able to see what was going on in the process when you do have a bad part and how you can fix that.
And think of medical applications too, or life sciences. A lot of times you're taking that data and you're storing it for the life of whatever you're making as well. So data collection is it's extraordinary. You have to have it, especially in a lot of facilities where you have to go back years down the line and take a look at it as well. Kind of what Stephanie was touching on too. With Promess system, you're able to take all of that data and store it to either a database or a local on the PC, or to a database as well. Not only that, but say if you're using any kind of data, a word here.
Oh, like an external database.
Yeah, like an external database, and you can take software and you like a QDOS or a QualityWorks as well, and you can examine that data and overlay your curves with the external software. But on the same end as ours, we actually have a software to where you can export every single one of those graphs, every one of those gauging data out to that database, and use our software as well to look over those graphs and data and overlays.
Yeah, as I say, the overlay is great, right? Because when you overlay all the data, and we can do that within our data utility, it allows you to look at trends and to see, what outliers there are. And then once you see what those outliers are, then you're able to kind of understand, okay, what was going on at that point, and what is there anything that I need to fix?
Yep, absolutely. And just utilizing that data even further down the line for storing locally or to the databases is a big thing. So.
Yeah, and I think that's a topic that we're going to be talking about more and more as the year goes on.
Yep, absolutely. So how can we accomplish this in the overall grand scheme of things?
Right, that's important. Everyone wants to know, okay, so you gave me ideas, you gave me ways to save, but how am I going to accomplish this? first and foremost, you have to look at controllability. The fact that we use a servo press,
Yep.
right? And we are able to control the speed and the variability within that press. And we have a controller, right? That's very simple and easy to program. Those are first and foremost, I think, the two biggest things to look at when you want to accomplish something like this.
Yeah, and like Stephanie said, and just kind of touching on, going a little bit, expanding out from the controllability side, you're able to press to a force, to a position, probe position. You're able to take in any temperature sensors, voltage sensors. From there, then you can also press to a force and slow down as you're pressing down on the part to get to your target force and be accurate with it. We're talking about being precise and accurate. There's ways with our press system, and it's fully programmable to decel down to a certain force or whatever your target function is as well.
Yeah, and just to expand on that, I've even worked on applications where we've taken in not just probe sensors and force and position sensors, but also pressure sensors, which are very tricky, right? But just being able to control that system down to a certain pressure and hold and maintain that pressure, we've been able to do that.
Yep. And think of also as well, say if you have some sort of like an air pneumatic press or a hydraulic press as well, you're coming down and you're pressing down on the part. At the same time, like on our servo systems, you can come down and press on that part, and say if you have a little bit of spring back within the part itself, you can then hold for a force and monitor what's going on while you're pressing to a force. So let's just say you're pressing down and you're holding a material that has to be glued together on it. When you're gluing those materials together and also heating it up, you have a little bit of expansion, or the glue is running up the sides. And from there, you will have force differences as well from there. At the same time, you can hold that force and have, say, a dead band to say if it ever goes out of a certain force range, that can compensate for that as well, and reapply force, change the position as well at the same time.
Yeah, that's also really helpful when you're working with any type of powder compaction, right? Being able to maintain that force over an extended amount of time. And you have to make sure that you have a system that is set up and able to do that, which we actually did a whole webinar on how to know, if I have the right system for what my application is, or how I even go about looking at purchasing a servo press. So that's something you can find on our website if that's something that you're interested in, or you could always call into Promess too, and we can help you with that. Another area though that we help our customers a lot when it comes to looking at the system is our product development center.
Yes. Yeah, so we do have a product development center here at Promess. Let's just say you have a part, you're unsure of what the forces are, we can size that press for you. If you do have parts, and then if it requires special tooling, you can send in to us and we can actually test your parts for you. So whenever those parts come in, we'll test them within a week. We'll get you force over position graphs on them and the data to be sent out. There has been some times that we've had some smaller parts that require more force. So you never know, like if you think your part requires 3 kilonewtons of force to press in, we found out it actually needs 8. Then you actually have that data now to go back and say, you can look at your part prints. Not only at the same time, we can size that press for you and say, this is what's going to need to press in your part all the way in. And at the same time, take that data back to your team as well and review it with them.
Right. So just to recap, and then we'll kind of go into our question and answer. The 3 ways to really reduce the cost on your manufacturing floor are reducing your scrap rate, improving part quality, and avoiding shipping bad parts. And really having a system that gives you the controllability, the programmability, and the closed loop feedback will help you accomplish those 3 things.
Absolutely. Well said.
All right. So let's take some questions. Looks like the first question we have is, how do you pass fail a part?
Pass failing apart. So within the system, there's a couple ways of going about it. There is a monitoring strategy that has your relative limits or your fixed high and low limits. At the same time, you can take points of that graph and put those into actual numbers to say what your actual interference fit was. So there's a couple ways of failing out a part. You can pass fail a part through if it ever crosses those relative limits that you have to your teach-in part, and also at the same time you're gauging as well. So, and all of that can be exported out to the station as well. So let's just say you're using an operator screen that has a pass fail on it. They can actually see that on the station HMI and also our Motion Pro and Ultra Pro
Yep, and a
Oh,
lot
it's
of
pro software, sorry.
yeah. So a lot of our customers will also integrate some type of PLC for
Yep.
a stack light so that there's a lot of notification that
Correct.
the part just is not a good part. What is the cost savings and maintenance to your press units? Oh, this is one of my favorite topics. So, you know, with our servo presses, really, there's no maintenance. You
Mhm.
have to grease the press
Yep.
like maybe every
It's once every
year.
quarter, every 250,000 cycles.
Yeah. But I would say most of our customers probably do it once a year
Yeah.
when they calibrate it. That's the recommended part,
Yep.
but yeah. And then there is just calibration of the sensors once a year. And that's it. There's no hydraulic pumps, there's no oil.
There's nothing else that's running on it that needs to be greased. Just the unit itself and calibrated. That's it.
Yeah.
And what would I save going from a hydraulic to servo technology? That's kind of a different question just because of the fact that there's a lot of variables that go into this as well. There is, and I believe that we're going to put up the study on here. There's a University of Kassel study that actually puts the servo technology out. It's around 90%, I think, efficiency
Yeah.
on it. And then hydraulics, you're looking about what, 57, 58%
Somewhere's in there.
efficiency on there. But it matters too on how many cycles you're running, how many days that you're actually running as well, and what your production schedule's like. To put an exact number on that's tough, but the number that you can actually put out with the efficiency of that press is pretty big numbers.
Well, I think the main thing to take away with this is that with a hydraulic or air pneumatic, you're constantly having to run that, you know, to keep it up. But a servo press is only using energy when it's doing any work. So if it's not working,
Correct.
it's not using energy.
Mhm.
And that's probably the biggest takeaway between that. What is the cheapest product that you have seen where a customer uses a Promess press? Um, hmm. So I'm assuming maybe they're thinking like, is their parts not expensive enough to use a Promess press? Maybe.
Yeah.
Um, I mean, we've used them even in golf balls.
Yeah.
So
Yeah, and that's something too. I mean, I've seen them used just as actuators before to lift a pallet and also work a cart back and forth. I've seen that before as well. And
I think that it doesn't really matter the cost of the part. It
yes,
really matters of what the process is to make the part and what you're needed, what controllability that you need, what data you want to have in order to make sure that the quality of the item that you're producing is a high quality and something that you're going to be proud of giving to your customers.
Yep.
All right, so I think that is all of our questions. I want to thank everybody for their time today.
Yes, thank you.
We are going to have another webinar in February. And I think
Yeah,
the topic just went blank.
It'll come up quick. But yeah, you can always reach out if you have an application that you want to talk to us on. You can always reach out to Promess. Visit our website, promissinc.com, or give us a call. Even if you want to chat about an application that you have, you can call us, and any applications engineer will speak with you. 810-229-9334 is our number.
Yes, and again, thank you all for attending, and we will see you next month.
Thanks, guys.